All right, guys, so we got test review 8 today. Most of it is over solving systems. Remember, we had 3 ways to do that: by graphing, by substitution, and by elimination. So we're going to go over those things and a few others. We're not going to do every problem on here. Of course, the keys are in my room. If you have any questions, let me know. We're going to skip over graphing. We're going to hit one here in just a minute anyway. So I just want to look at this and make sure you know this means you got to find the intersection. Which means you're going to have to solve for y to graph them. We'll look at one of those here in just a minute. Remember, there's 3 ways they either intersect and we have a point for our answer. They're parallel, so there's no solution because they'll never intersect, or they end up being the same line, meaning there's infinite solutions. Let's scroll down a little bit. I would like to look at number 3. Now, number 3 is similar to the other ones. We want to solve the system and shade the solution area by graphing. So the first thing we have to do is graph them. So if I look here, it's set up for me pretty nicely. I can tell my slope is -5/2 on the top one, and that I have a y-intercept of 0, -2. So I'm going to go over and graph that. I start at 0, -2. My slope is -5/2, so that's down 5, right 2. 1, 2, 3, 4, 5, 1, 2. I can't go any further in that direction, so I'll go the exact opposite, which would be up 5, left 2. 1, 2, 3, 4, 5. And I notice that it's a less than or equal sign, so that is a solid line. So I'm going to go ahead and sketch that in. There we go. And then it also says that y is less than or equal to, so I'm going to shade below my line. Now I'm going to go over to the other equation. Let me switch colors on you here. It looks like its slope is -1/2, and my y-intercept is 0, 2. So let's go over and look at that one. So I've got 0.02 here. -1/2 will be down 1, right 2. So down 1, right 2. It looks like that's moving away from the other line, though, so I'm going to go the exact opposite, which would be left 2, up 1. And then it looks like that I need to do a dotted line because it's less than. This is also less than, so I'm going to shade below my line. And then we can find the overlap. And if you look here, looks like we have an overlap in this region. So be careful when you graph them. I do think I miscounted on one of the points, so even anyone can mess up. I think this one should have been a little bit lower right there. But once you shade the region, you have your answer set. Now this kind of goes into the next question. It says, which of the following points are in the solution to equation number 3? Some of them may be hard to see. Remember, if they end up being on our dotted line, that's not going to work. You could plug them into your equations and see what works. If you look over at -2, 0, that does appear to be in our shaded region. I'm going to go ahead and circle that one. 2, -1 is not in our shaded region. 3, 3 is definitely not in our shaded region, but -5, 0 absolutely is. So these were kind of easy to see. But again, just plug them into the equations. If they work, then they're solutions. Let's go to the next page. We've got a couple of calculator-type questions. It says use the following table to determine the solution. Well, if it's a solution, then the y's must match. So we're looking for an x value that has the same y value. So if I look through 1, -3 doesn't work, 3, 1 doesn't work, but then I have 5, 5. So I want the x and y value, which is 0.05. Don't use 5, 5 for your answer. It's the x value and then the y value. So you can do the same thing on the next one, see if any of the y's match up. They do not, so that would be a no solution. If they all matched up, that would be infinite many solutions. All right, guys, let's go down and get some real work done. If you go to the next page, we're going to skip this substitution, and we're going to do one elimination. We'll get to substitution and graphing here in just a second. I want to do this top problem. I got 5x minus 9y equals -3, and 4x minus 3y equals 6. And I want to solve this by elimination. Now, remember on the test, if I say elimination, do elimination. If I say substitution, do substitution, and so on. It doesn't look like anything's going to be eliminated easily. I'm going to go ahead and draw my parentheses around both equations. And I'm going to choose to cancel out the x's. So I'm going to multiply the top equation by 4 and the bottom one by 5. Notice where I got the 4 and 5. It's just from the opposite equation. They have the same sign, so I need to make one of mine negative. It does not matter which, so I'm just going to make my negative 4. Let's distribute across the parentheses. Negative 4 times 5x is negative 20x. Negative 4 times negative 9y is 36y. And negative 4 times negative 3 is positive 12. So I got my first equation fixed. Now let's go ahead and do the same thing to the other one. 5 times 4x is 20x. That's going to give me my elimination. 5 times negative 3y is negative 15y. And 5 times positive 6 is 30. So I have my new system here. It's adjusted. Something will eliminate. Negative 20 plus 20. That's going to be gone. And that's 36y. I hope I said that when I did it a second ago. 36y minus 15y gives us 21y. And 12 plus 30 gives us 42. So now I have an equation that I can solve for a variable. I divide both sides by 21, and I get y equals 2. Now that I have my y value, you can go back and plug it into either equation. I'm going to go ahead and do it to the top one. I'm going to say I'm going to use 5x minus 9y equals negative 3. And I'm going to plug my y back in. So I have 5x minus 9 times 2 equals negative 3. Now I can go ahead and solve that. That's 5x minus 18 equals negative 3. I have to add 18 to both sides. And I get 5x equals 15. And now I can solve by dividing both sides by 5. And I get x equals 3. Now remember, when I ask you for the answers, I want the solution. That's a point. This would be our x value 3 followed by our y value 2. So there's an elimination example for you. The next one does pretty much the same thing. Remember, if you need any help on that, the keys are in class. You can always ask me. Let's go down and do some graphing and substitution. Now, there's going to be questions on the test that maybe make you do a problem different ways. Like maybe they say, here's a problem, do it by graphing and do it by substitution. So that's what we're going to do here. It does say elimination as well. That will be an option on your test, but we just did one. This one's actually a little bit easier in the elimination area. So let's go ahead and look at this one. We're going to do A first, the graphing. Remember, when we have to graph, we got to solve for y. So I have my two equations. Let's see, 5x plus 2y equals 4. And then my other equation, x minus y equals 5. So I'm going to solve both of these for y, and then I'm going to graph them. I need to move my x's first when I'm solving for y. I subtract 5x from both sides. I get 2y equals negative 5x plus 4. Now I don't need that 2 attached to y, so I divide everything by 2. And I get my equation solved for y to be y equals negative 5 over 2x plus 2. Now I can get my slope and y-intercept. It looks like m is negative 5 over 2, y-intercept 0, 2. So I'm going to go ahead and plot those real quick and see what my line looks like. Let's see, we start at 0, positive 2, so I go 0 up 2. There's my first point. And then my slope is negative 5 over 2, so down 5, right 2. 1, 2, 3, 4, 5, 1, 2. There's another point. 1, 2, 3, 4, 5, 1, 2. So we got a few points here. Let's connect them together with our line. Now that we have our first one done, let's go back over to the second. Again, I'm going to move my x's first so that I can solve for y. I have negative y equals negative x plus 5. But I can't have negative y, so I can fix that by dividing everything by negative 1 or multiplying everything by negative 1. And I got y equals positive x minus 5. So my slope here, in front of the x, there's really a 1, so it's 1 over 1. My y-intercept is the point 0, negative 5. So I'm going to go graph this one as well. So over 0 down negative 5, 1, 2, 3, 4, 5. It's positive 1 over 1, so up 1, right 1, up 1, right 1. I think I just saw the intersection. So I'm going to sketch in my line. Remember, that's what we're looking for, is this intersection point. So count carefully. It looks like it's over positive 2 down 1, 2, 3. So it looks like my solution is the point 2, negative 3. So that's basically what you do when you graph. That's how you can do this first couple of problems on the page. Remember, when you're graphing, you have 3 types of answers. This was one where I had an intersection. Had they been parallel, had equal slopes, there would be no solution. And if they were the same line, they would end up being infinitely many solutions. So that's how you do it by graphing. And what's nice is if we're doing substitution, graphing can kind of help us out. So let's go to substitution. This is where we want to solve one of our equations for a variable and then plug that into the other equation. So it looks like we already have some of our stuff solved. We did it in the last problem. So I'm going to say that I have y equals x minus 5. And that's the one I'm solving for my variable. Notice I had that right over here, so I didn't have to rework it. Now I'm going to plug that into the other equation. Y equals x minus 5 is this one solved for y, so I'm going to plug this into 5x plus 2y. So I have 5x plus 2 times my new y value, x minus 5, equals 4. Now, when you plug in your variable, the variable is gone. It's replaced by the equation. There is no y left. It's x minus 5 because y equals x minus 5. Now, I need to do a little distributing. I can solve for x. I have 5x plus 2 times x is 2x. 2 times negative 5 is negative 10 equals 4. I have some like terms I can combine. 5x plus 2x is 7x minus 10 equals 4. Now I'm going to have to add my 10 to both sides. I'm trying to get 7x by itself. I'm going to come up here. So now I have 7x equals 14. Then I can divide both sides by 7, and I get x equals 2, which is what it should be. That's what it was when we graphed. Now the difference between graphing and substitution is once we get that x, it's a lot like elimination. I need to plug that into either equation. So I'm going to use my y equals x minus 5. And I'm going to plug my 2 in for x. So I have y equals 2 minus 5. And so I have y equals negative 3. So again, my solution is the point, and it's 2, negative 3. Now you can do this one in elimination as well. You have a couple of choices. If you wanted to do it, we're not going to do it on this, but remember elimination we already did one of. I could probably multiply this bottom one by 2 the whole way through. They can be 2y, negative 2y, and then I could do it by elimination. Let's flip over to the back page and finish this up. These next few are pretty easy. It's kind of like they'll look at a calculator again. We can do them real quick. This is, if they're graphed for us, it wants the solution for all three. Well, if they're intersecting on a graph, we want the intersection. Looks like if I count that one over, it's going to be 0.22 where they intersect. The next two, it doesn't show us an intersection. They look like they're parallel. When things are parallel, there is no solution. If they do not intersect, there is no solution. And the last one weirdly only shows us one line. If it's one line, that must mean that that's the only thing for both of them. So this would be infinitely many. You could pick any point on either line, and it's on the other one since they're the same. Now, number 16 is a pretty quick and easy one as well. It says determine if 5, 1 is a solution to the system. Well, guys, we have 5 as x, y is 1. So if we just plug those things into these x's, if they work, then we have an answer. If they don't, then we don't. So 5 times 4 would be 20, minus 7, that would be 13. 2 times 5 is 10, minus 7 times 1 is 7. That would also be 3, so our answer on that one is yes. So plug them in and check them out. All right, so we have two problems. These are a little bit tougher, but you should be able to get equations, no problem. This one wants us to write the system. So when it says write the system, that means it wants the two equations. It's not asking us to solve or do anything like that. I'm going to go ahead and try to write the equations for both these lines. I'm going to call that line A and line B just to keep myself straight. So I'm going to use this one to get line A and this one for line B. It looks like line A is a dotted line. Remember, a dotted line means it's either less than or greater than. It looks like if I look at my dotted line that I've shaded below, so I know that in my system it's going to be a less than sign. Y is going to be less than my equation. So I need to find the slope of these lines, and I need to find the y-intercept. So if I look at the y-intercept on my dotted line, it looks like it crosses the y-axis right here at -3. So that means I have a -3 on the end. I know I have my x. I just have to find the slope, and I've got it. I'm going to erase this a little bit here to keep it clean. Change colors for us. To find the slope, I need 2 points. It looks like that's a nice, easy point to see. It looks like it's 0, -3. If I move up here to the intersection, it looks like another solid point. So it looks like I have a 1, 2, 1, 2, 3, 4. I have a negative slope. because it's down and to the right. If I count my rise over run, it looks like I get 1, 2 over 1, 2, 3, 4. So 4 over 2, or 2x minus 3. So I have my first one. Count your slope carefully. You know, if you mess up the inequality, that's not a horrible, horrible thing. At least get the equation right. So now I'm going to look at my line B. I know it's also y. What's going on here? There we go. It's a solid line, so remember solid lines have to be equal to as well. It's got a positive slope. It looks like if I kind of sketch this in, it would be shaded below, so y is less than or equal to. So now I need to find the y-intercept. It looks like it crosses right here at positive 2, so I know I'm going to have x plus 2. Now I just need to find some points and find the slope. A good point is right here at 0, negative 2. We'll use this point early on the other one. Looks like I have a negative slope again. I mean a positive slope, I'm sorry. My run is 2, my rise is 1, so I have 1/2 x plus 2. Now that's kind of tough, guys, but you should at least be able to get the slopes and the y-intercepts. Then you just plug it in. Be careful in your equalities. The next one, it's not an equality. It just has a point. So remember, it's going to be y equals on at least one of them. I have a horizontal line here, and if you guys don't remember, a horizontal line is always y equals. It passes through the point -1, so I have y equals -1. Now the other one's going to be y equals as well. Looks like it has a negative slope down and to the left. It crosses my y-axis at positive 4, so I'm going to have something negative, something x plus 4. Now I just need to find the slope again. Let me erase some of these. Looks like I have 2 good points, one right here and here. If I count that, I have a run of 2, a rise of 5. I know it's negative, so 5 over 2x plus 4. Be careful on that one. That is a little bit tough. If you take your time, that won't be so bad. And this last one, guys, it says write the system and find the solution. This is meant to be pretty much a straight-up calculator problem. I'm going to put calc over here to the side. The first thing you could do is use your stat to find the equation. You can put this into L1, L2, find the equation. Same thing here, L1, L2. And then you'll have your equations down here. If you throw them in your calculator, you get y equals 1.5x plus 4 for one of them. And the other one you get y equals x plus 6. Now once you get those guys, graph them in your calculator. Graph in calc. Once you do that, you can use the intersection button to find the answer. And of course, we can go over this in class. Sorry, my tablet just messed up there. You're trying to find the intersection. That's what that says. And if you do this correctly, the solution should be 410. Guys, it's a lot of stuff on this test. It's a lot of repeating stuff, a lot of substitution elimination. Make sure you can do the calculator stuff. It'll help you out on a lot of the problems. So I hope that helps. Good luck.